Hi girls, so tomorrow we're going to talk about exact trig ratios, and so I'm just going to show you a quick video how to find them. So we do it by creating triangles that are nice. And what I mean by that, so we need right angle triangles because we're going to do SOHCAHTOA. And so we do triangles where we know something about the side ratios already. Oops. Nope, I've got to remember how to use this thing. So, here's a right angle triangle, and we're going to say that it's isosceles. Right? And because it's isosceles, means I can pick the side lengths, and I'm going to pick them to be 1. Right? It'd be silly to pick them to be 7, might as well pick them to be 1. And then I use Pythagoras to tell me that there is pi over 2, sorry, root 2. Now, the angle in here is the same as the angle here, right? They're the same. The angle sum of the triangle must be 180 or pi. I've already got this angle here, which is 90 or pi over 2. So these two add together to give pi over 2, and they're equal, so they must be pi over 4. And this tells me the first 3 exact trig ratios. Right? It tells me that sine pi over 4 is opposite over hypotenuse, 1 on root 2. Cos pi over 4 is adjacent over hypotenuse, that's 1 on root 2. And then tan pi over 4, well that's opposite over adjacent, and it's 1. Alternately it's sine divided by cos, and it's 1 in each case. Okay. Effectively you need to memorize these, but realistically what we should do is memorize the construction of the triangle, and you will use these enough that you'll kind of know roughly what they are, and you can go from there. So the other ones are slightly more complicated construction, but not heaps more. So we've used an isosceles triangle. The other nice triangle, like you don't want to use a scalene obviously, so the other nice one would be a equilateral triangle. So these angles are all 60 or pi over 3. Now that's nice, but there's no right angles in there, sorry, I should say. So I create one by drawing a perpendicular line from the top. And there's a theorem that says that a perpendicular line is also a bisector. So this length here is the same as this length here. Right? In other words, the base of my new triangle, when I kind of pull it out, is half of the base of the original equilateral triangle. And I might actually draw that a bit bigger just so I can use it better. Okay, so this angle here is pi on 3, or 60. 60 degrees is 180 divided by 3. This angle here, using angle sum of a triangle, is 30, which is pi divided by 6. 180 divided by 6 is 30. So then, I say, well, what do I want the side lengths to be? I can make them be whatever I want, effectively. But, well, if I say that the side length here is 2, that means the base is 2, which means that the base of this triangle here is half of 2, or 1, right? So I end up with a triangle with a side length 2, side length 1. Like, obviously you could pick 10 and get 5 and things like that, but why would you? And if I use Pythagoras, it's fairly easy to see that that one there is root 3. And again, basically I want you to memorize this triangle, right? This is the, nah, stop it. This is the thing to memorize, right? Not the numbers I'm about to write down, because there's a lot of them. And then you say, alright, well, sine pi on 3, opposite over hypotenuse, cos pi over 3, adjacent over hypotenuse, and then tan pi over 3, opposite over adjacent, or just root 3. And then exactly the same for pi. You'll start to, I hope, notice some patterns. So, oops, why did I start with tan? So sine pi over 6 is 1 on 2, which notice is the same as cos pi on 3. Cos pi on 6, I'm starting to remember why I stopped making these videos. It's really annoying using the iPad, to be honest. It's root 3 on 2, and then tan is 1 on root 3. Right, I'll write it down here. Now it's hard to memorise all these. I personally don't memorise all these. Right? If you ask me what one of them is, you'll see my eyes raise and go to probably the right, I think, which means I'm thinking and I'm recalling this triangle here. Right? I'm basically drawing that triangle in my head, which I can do because I've done it enough times, and then working out the relevant ratio. And that's what you should be aiming to do. But first, what I'll get you to do is every time draw the triangle. Now, the next thing that we'll do, and I'll do this very briefly, is then I'll say to you, well, what is sine 5 pi on 6? Well, 5 pi on 6, that's 5/6 of the way around one, so it's over here somewhere, right? Which makes this angle in here the related angle, pi over 6. I then move that over to the first quadrant, and the idea is that they then have the same y-coordinate, and I've got a unit circle drawn here, right? I just haven't actually drawn it. So in other words, and it's all stations, so sine, because it's a y-coordinate, is positive. So it's exactly the same as sine pi over 6. Scroll back to my exact ratios, sine pi over 6 is a half. So it's exactly a half. Okay, that's how we use it. And we do the same thing with a lot of different angles in place here, and with sine, cos and tan there. Okay, that's all for this one. See you tomorrow.